Hi everyone, welcome to one of the most important topics of number properties, that is prime numbers. Along with prime numbers, we'll also be covering HCF and LCM in this lesson. So let's start. So what are prime number? So prime number is an integer greater than 1 that has no factors other than 1 and the number itself. So prime number has only two factors, that is 1 and the number itself. 1 is not considered as a prime number and 2 is the smallest prime number, and it is the only even prime number. So one thing, if possible, remember this, that there are 25 prime numbers between 1 and 100. You never know that when it comes for use in GMAT. So here below I have written all those 25 numbers between 1 and 100. 3, 5, 6, 11, 13, 17 and so on up to 97. Another interesting concept is a co-prime number. Co-prime number are a pair of two numbers which need not be prime. Although the name says co-prime, but the co-prime numbers need not be prime. We call numbers as co-prime if they do not have a common factor. For example, 8 and 15 are co-prime numbers. So because 8 can be written as 2 into 2 into 2, 15 can be written as 3 into 5. So there is no common factor between these two numbers. Two prime numbers are always co-prime with each other. Next important thing is prime factorization, which is a very simple thing. Prime factorization is nothing but to express a number as a product of prime factors. Okay, so for example, let's take 36. 36, if we have to divide into the prime factors, so first we divide it by 2, we get 18. Then we again divide by 2, we get 9. Then we divide by 3, we get a 3. So 36 can be written as 2 into 2 into 3 into 3. Similarly, let's say 300. So 300, when I divide by 2, I get a 150. Then again I divide by 2, I get a 75. Then I divide by 3, I get a 25. Then I get a 5 and a 5. So 300 can be written as 2 into 2 into 3 into 5 into 5, or 2 square into 3 into 5 square. So this is called prime factorization, which is a basic concept. Now let us touch upon what is the highest common factor or the greatest common factor. HCF is nothing but the greatest number which is common factor of two or more given numbers. Okay, let's see an example. Like in the previous example, we have seen 36 and 300. So 36 was 2 square into 3 square. 300 was 2 square into 3 into 5 square. So the common prime factors in 36 and 300 are 2 and 3. In 36, there is no 5. So to find the HCF, what we do, we find the lowest exponent number of 2 out of two numbers, which is 2. In both the numbers, it is 2 only, and of 3. The lowest exponent of 3 here is 2 and here it is 1. So the HCF is equals to 4 into 3, which is equals to 12. So this is a way to find an HCF. So HCF here is 12. So what you need to do, you need to take all prime factors with lowest powers to calculate the HCF. Now let us try to find HCF by another method, which is a prime column method. So what we'll do, we'll create a column for each prime factor base and row for each integer. So the different prime factors above are 2, 3 and 5. So we say that the different prime factors are 2, 3 and 5. So you need 3 columns and there are 2 integers, which is 36 and 300. So you need 2 rows. If we see that 36 is equals to 2 square into 3 square into 5 raised to power 0. 300 is equals to 2 square into 3 raised to power 1 into 5 raised to power 1. To find the HCF, as we said that take all prime factors with lowest powers. So the lowest power here can be 2 square, here it is 3 raised to power 1 and here it is 5 raised to power 0. So HCF is equals to 2 square into 3 raised to power 1 into 5 raised to power 0, which is nothing but 4 into 3 into 1, which is equals to 12. So this is another way by using prime columns to find an HCF. Now let us understand what is LCM. LCM is nothing but a lowest common multiple. Lowest common multiple of two or more numbers is the smallest number which is multiple of each of the numbers. So as we said, 36 was 2 square into 3 square. 300 was 2 square into 3 into 5 square. In HCF, what we did, we took the lowest power of each of the prime factors. But to calculate LCM, what we'll take is, we'll take the highest power. So the highest power here is 2 square, here it is 3 square, here it is 5 square. So LCM of these two numbers will be 2 square into 3 square into 5 square, which is nothing but 4 into 9 into 25. So we get the LCM here as 900. So the LCM of 36 and 300 is 900. It means that 900 is the lowest common multiple of 36 and 300. It is divisible by 36 as well. 900 is divisible by 300 as well. This is the LCM concept. Now let us study one of the important topics of prime numbers, which is a prime box. Prime numbers are normally tested in the data sufficiency questions. A prime box is exactly what the name suggests, a box that holds all the prime factors of a number. So as we said, 36 was 2 square into 3 square. Okay, so what we write in the prime box of 36 is 2, 2, 3 and 3. So we have written all the prime factors of 36 in here. 300 was 2 square into 3 into 5 square. So here the prime box of 300 is 2, 2, 3, 5 and 5. Simple. Now let us see that how these prime boxes help us to solve the issues. Example of the question is 18 a factor of 300? Is 18 a factor of 300? How do we solve this problem? Let us split 18 first. 18 is equals to 2 into 3 into 3. Okay, so 18 requires 1 2 and 2 3s. If 18 is a factor of 300, or if 300 is a multiple of 18, the prime box of 300 must have at least 1 2 and 2 3s. However, the prime box of 300 has only 1 3. So 18 cannot be formed by the factors present in the prime box of 300. So 18 is not a factor of 300. 18 is not a factor of 300. Now let's see another example. Given that integer n is divisible by 54 and 4, is n divisible by 36? So let's try what is 54 first. 54 is nothing but 2 into 3 into 3 into 3. Okay, 4 is nothing but 2 into 2. Okay, so we calculate first the LCM of 54 and 4. The LCM of 54 and 4 is equals to 2 into 2 into 3 into 3 into 3, which is nothing but 108. So 108 is nothing but a multiple of 54 and 4. Since n is divisible both by 54 and by 4, that's why n is also divisible by 108. So let's create a first prime box of 108. If we create the prime box of 108, we get 2, 2, 3, 3, 3. This is the prime box of 108. If n is a multiple of 108, how the prime box of n will look like? Prime box of n will look like having all the factors of 108 plus some other factors which we don't know. But at least prime box of n will contain the factors 2, 2, 3, 3, 3, which is nothing but 108. Now we need to see, is n divisible by 36? If n has to be divisible by 36, so the factors of 108, there must be some combination which should be making 36. So what is 36? 36 is 2 into 2 into 3 into 3. So in the prime box of n, we have 2 2's and 2 3's. Hence, n is divisible by 36. Okay, so this is how simply we can use the prime boxes to find the solutions of complex issues. To summarize, first factor both the numbers, like I have factored 54 and 4. Then find the LCM of 54 and 4, 108. So we get the prime box of 108, which contains 2, 2, 3, 3, 3. Then the prime box of n will definitely contain these factors plus some other factors. Okay, so since 36 requires 2 2's and 2 3's, and it is also available in the prime box of n, hence n is also divisible by 36. Now let us see how these questions are tested in the data sufficiency questions. Is y by 36 an integer? So it is asking that, is y a multiple of 36? Okay, similar question. So 36 is equals to 2 into 2 into 3 into 3. So the prime box of y should contains 2 2's and 3 3's if it is a multiple of 36. Okay, let's say statement 1. Since it's a data sufficiency question, we write AD, BCE. Let's take the statement 1 first. If y is divided by 54 and 4, remainder is 0. Hence, y is a multiple of 54 and 4. So 54 is equals to 2 into 3 into 3 into 3. 4 is 2 into 2. So the LCM of 54 and 4 is equals to 108 as calculated in the last slide. So the prime box of y according to statement 1 will be 2, 2, 3, 3, 3 and some other numbers. So it contains 2 2's and 2 3's. Hence, statement 1 alone is sufficient to answer is y by 36 an integer or not. So we strike off BCE. Now let's see statement 2 alone. Y is a multiple of 27 and 4. So 27 is nothing but 3 into 3 into 3 and 4 is nothing but 2 into 2. LCM of 27 and 4 again is 108. Okay, so according to statement 2, the prime box of y contains 2, 2, 3, 3, 3. So again it is sufficient to answer that y by 36 is an integer or not. So our answer option is D. So we have used LCM, we have used prime boxes, and we have also used the factor foundation rule to find our answer. Now let's see another question. Is A divisible by 24? So similarly, if A has to be divisible by 24, in the prime box of A, there should be factors required to make 24. So now 24 is equals to 2 into 2 into 2 into 3. 2, 2, 2, 3 and some other factors. If A contains 3 2's and 1 3, it can be divisible by 24. Now let's see the statement 1 alone. Statement 1 says A is multiple of 12. 12 is equals to 2 into 2 into 3. So by this, we cannot say alone that statement 1 is sufficient, that A is divisible by 24, because it requires 3 2's. So since it's a data sufficiency question, let me write A, D, B, C, E. Since the statement 1 alone is not sufficient, so I strike off A and D. Okay, now let's see statement 2. Statement 2 says that A is a multiple of 10. 10 is equals to 2 into 5. So the statement 2 alone is also not sufficient to answer the question. Now let's take statement 1 and statement 2 together. LCM of 12 and 10, 2 into 2 into 3 into 5, which is nothing but 4 into 3, 12, 60. LCM of 12 and 10 is 60. Now the prime box of 60, if we consider the prime box of 60, it contains 2, 2, 3 and 5. However, for the 24, we require 3 2's and 1 3. Okay, so these two statements combined together also are not sufficient to answer whether A is divisible by 24. It may be possible that there are some other factors which might be there. So the answer option of this question is E. Okay, because we are not able to answer whether A is divisible by 24 or not. If it was given that A is divisible by 8 as well. Okay, so in this case we find LCM of 12, 10 and 8. What it would have been? 2 into 2 into 2 into 3 into 5, which is nothing but 120. Okay, so if we make the prime box of 120, it contains 3 2's and 1 3. In this case, we would have been able to say that A is divisible by 24. But with these two statements alone, we can't determine that whether A is divisible by 24 or not. So this is how data sufficiency questions are tested on GMAT. Now let's take some simple examples related to prime numbers. So one of the data sufficiency question is, what is the value of integer x? Okay, this is a value question of data sufficiency. So statement 1, it says that x has exactly 2 factors. So we know that all prime numbers have exactly 2 factors, which are 1 and the number itself. So by statement 1 alone, we are able to tell that x is equals to prime number, but we are not able to tell that what is the value of x. Hence, statement 1 alone is not sufficient, so I strike off A and D. Now let's take statement 2. It says that x is an even integer. X is an even integer. It can be 2, it can be 4, 6, 8 and so on. It does not tell the value of x alone. So statement 2 alone is also not sufficient. So if we combine S1 and S2, we get that x is equals to prime number plus x is equals to even integer, and we know that only prime number which is even is equals to 2. So by statement 1 and 2 alone, we are able to get the solution. So for this, C is the answer. By the properties of prime number, we are able to solve this data sufficiency question. Let's see another simple example. It is given, if A is a prime number, what is the value of A? It is given that A is a prime number. So let's write first AD, BCE. So statement 1, what does statement 1 says? There are total of 50 prime numbers between 2 and A inclusive. So there are 50 prime numbers with 2 and A inclusive. So we say what are the prime numbers? 2, 3, 5 and so on. We know that the 25th prime number between 2 and 100 is 97. So here it's a data sufficiency question. We are not asked to find what is the value of A. We are just asked can we find for statement 1. So if we do some maths around this, definitely if we keep on writing the prime numbers ahead, we'll be able to find that what is the 50th prime number from this statement. So statement 1 alone is sufficient to answer this question. So we strike off BCE. Okay. So let's go to statement 2. Statement 2 says there is no integer n such that a is divisible by n and n is between 1 and a. So what does this say? This is a very simple statement. It is actually saying that a is not divisible, a is not divisible by any number. So that means it is saying that a is a prime number which is already given to us in the question stem. So statement 2 alone is not sufficient to answer the question. So the answer to this question is A. So this is how the prime numbers are tested on GMAT. These are some of the examples. But since prime numbers, LCM, HCF are some of the important topics in the number properties which are tested on GMAT, so we'll see some other video also on the subject. Okay. Till that time, thank you so much. Bye bye.